All right, let's look at the homework 4.7, problem number 4. All right, so it's a tutorial exercise. All right, so we want to find the points on the ellipse that are farthest away from the point -1, 0. All right, let x, y be a point on the ellipse. Okay, we must maximize the distance between this point and the -1, 0. So the distance is x minus -1, so it's going to be +1, and y minus 0, so it's at 0 there. So let's submit. All right, so we got that, and let's go to part 2. All right, since the point x, y is on the ellipse, so you solve the equation for y squared, and we'll optimize d by maximizing d squared. All right, so d squared is just this guy inside, and let's see. So you have x plus 1 squared, so that's the first part. All right, because of the square, square root is gone. All right, so instead of y, instead of y squared, you're gonna put the 4 minus 4x. So you have 4 minus 4x squared, and then you just have to multiply out. So I'm gonna just multiply out. Hold on a sec. All right, we just need to multiply out. So you have x squared plus 2x plus 1. And we're adding 4 minus 4x squared. All right, so we can collect the like terms. X squared term, it's going to be 1 minus 4, so it's a -3x squared. All right, then you have only one x term, so it's going to be plus 2x. And then we can combine 1 and 4 together. So that's going to be plus 5. All right, so let's type it in. All right, so it's going to be a -3, and that was 2x plus 5. All right, let's submit. All right, it came back and looks like we got the part 2 correctly. All right, let's look at part 3. To optimize s, we solve 0 equals s prime. So you just have to take the derivative of that, which is going to be put 2 times -3 is -6 x, and the derivative of 2x is 2, right? And therefore x is, so if you set that equal to 0, we can probably do it by hand, right? So put -6x over to the other side, becomes positive 6x is equal to 2. So divide through by 6. So 2 divided by 6 is 1/3. So x is equal to 1/3. All right, let's submit. All right, it came back and looks like we got the part 3 correctly. All right, let's look at part 4. All right, so we're going to take the second derivative. Looks like second derivative is just going to be -6, right? So you have -6, which is negative. Yep. Then s is a maximum at x equals 1/3, which we had before. That's the critical number. There are two y values for this x value dot r. All right, so we know that x is 1/3. And what was the y equation? So here's the y equation. So let's copy that. So I'm going to just copy this. All right, so copy this value there, not the value, expression there, and let's solve that one. All right, so here. All right, so since x is 1/3, right? So we just have to plug in. So you have a y squared is equal to, because x is equal to 1/3. All right, so it's going to be 4 minus 4, and then we have a 1/3 squared. All right, so then this is going to be equal to 4 minus 4 over 9. All right, so What's for common denominator? So it's 9. And 4 times 9 is 36. Minus 4. That's going to be 32 over 9. Right? And so this is plus or minus. So y is going to be equal to, by taking a square root, it's a plus or minus square root of 32 over 9. Right? What's this? Hopefully this is, so square root of 9 is 3, so 3 is on the bottom. All right, 32, so let's break it down. 2, 16, so it's a 4 times 4. So it's going to be a 4 square root of 2. All right, so let's type it in. All right, so, oh, actually, we can just do 32. All right, so let's submit. All right, I came back, so we got the part 4 correctly. All right, so last part. All right, so x is, we know that it's 1/3 and 1/3, right? And then large y value is the positive version, so it's going to be what was it? 4 square root of 2 divided by 3, right? Let's see. I have to highlight this. Divide by 3. Right, and same thing, so maybe I can copy and paste, hopefully. All right, and smaller, so it's going to be for the negative one. All right, so let's submit. All right, it came back, and looks like we got the last part correctly. Now it says, yeah, you have now completed the master it. All right, that's it. I hope that this was clear.